Hello viewers, question 8 sees us solving a very similar question to question 7. We have two unknown forces here, F1 and F2. The whole system is allegedly in equilibrium. We need to find what those two forces are, which makes equilibrium the case here. Okay, so let's draw our force table. So we've got force, we've got horizontal and vertical components. Let's start with the 11 meganewton force. Horizontal component is 0 because that is a vertical force. Vertical component is 11 and it's upwards, therefore positive. Now below the horizontal on the right at an angle of 6 degrees we've got F2. So its horizontal component is going to be the adjacent side and therefore the cosine side. Angle is 6 degrees and its size is F2 and it is pointing to the right, which makes it positive. Now the vertical component is the opposite side and therefore the sine side, sine of 6. F2 is its size, pointing below the horizontal, pointing downwards makes it negative. And below the horizontal as well, on the left, we have at a 15 degree angle, F1. So our horizontal component it's negative because it's pointing to the left. Its size is F1. We're dealing with the horizontal component, which is the adjacent side. So this is going to be causing the angle is 15. And the vertical side is the opposite side, therefore the sine side, and its size is F1. Pointing below the horizontal makes that negative. If it's in equilibrium, we know what the totals should be, 0. So the totals here are 0, and we can work out our two equations. So from the FH column, we've got 0 plus F2 times cosine of 6. So we've got F2 cosine of 6 minus F1 cos of 15 equals 0. And we're going to solve that for F2. So we'll move the F1 cos 15 to the other side. We get F2 times cosine of 6 degrees equals F1 cosine of 15 degrees. And we want F2. At the moment the left hand side is F2 times cosine 6 degrees. So therefore we need to divide by cosine 6 degrees to get F2, which is F1 cosine of 15 degrees divided by cosine of 6 degrees. So that is an expression for F2, which we will need in a minute, but let's turn our attention to the FV column. So from the FV column, what have we got? We've got 11 minus F2 sine of 6 minus F1 sine of 15 equals 0, which if we rearrange that we get F2 times sine of 6 plus F1 sine of 15 equals 11. Okay, so that was by moving the F2 sine of 6 and F1 sine of 15 terms to the other side. Now we've got on the first page of the solution, at the bottom we've got an equation for F2, which we can substitute into this equation, because the goal here is to solve for, if we've got an equation for F2 already, and substitute that into our equation, we're going to get an equation that only has F1 in it. And then from that we can solve for F1. So if we make that substitution, F2, which we have just found to be F1 cosine 15 over cosine 6. So that was our equation for F2, but we've got F2 sine of 6, so we've got to multiply that by sine 6 plus F1 times sine of 15 equals 11. So we've got two terms, an F1 in this term and an F1 in that term, both of them multiplying whatever the rest of the term is. So we can take out that F1 as a common factor. So we've got F1 multiplied by what's left is cos 15 over cos 6 times sine of 6 plus, we've taken out the F1, so that's just sine 15 here, equals 11. So F1 times a mess equals 11, and therefore F1 equals 11 divided by the mess in question. So we've got cos 15 over cosine of 6 times sine of 6 plus sine of 15, and we've got now something that we can calculate, and if we do that whole calculation we get 30.5 meganewtons. Okay, so we have F1. Now we've got an equation for F2. All we need to do is substitute our value of F1 that we've just found into that. So we've got F2 is, let's just rewrite that equation that we've already found, F1 cos 15 over cosine 6. That's what F2 is in terms of F1. But we have a value for F1 now, which is 30.5 times cosine 15 divided by cosine of 6. And calculating that, we get 29.6 meganewtons. Okay, thanks for watching. Over and out.